Okay, so I'm going to go over this oxidation problem that you gave me, and it's kind of a good one because there's a little bit more to it than meets the eye, and we'll talk about that. All right, so first thing is you're given this chemical equation, and so we have to figure out the oxidation of each one of the substances. Okay, so Cr2O7 2 minus, and OH minus, and CrO4 2 minus, and H2O. What are the oxidation numbers of each of the elements inside these substances? Okay, all right, so that's what we want to find. So we're going to start out with a Cr2O7 2 minus, and so it has two elements. It has chromium and oxygen. And to figure out the oxidation number, we're going to use oxidation priority table. And this is my thing, okay? I haven't found it in books or anything like that. It's just the way I'd like to put it out there to envision how to figure out oxidation numbers. So the idea is, so here are the elements with the oxidation numbers. You notice there's only, not every element has its own oxidation number. There's only a few of them, okay? And that's because you can figure out most any of the oxidation numbers based on these guys here. And the idea is you look at your substance, the chromium and the oxygen, and what you need to do is leave one of them unknown, okay? So you go over to the table and you find which one of the two are higher up on the table. Okay, you see oxygens, but you don't see chromium. So obviously oxygen's higher than chromium. So that means you know the oxygen's oxidation number, which is -2. Now it's just a little thing about oxidation numbers. They're related to, but they're not the same thing as the ionic charge. They actually found these oxidation numbers before they did the charges, and so what this is, so oxygen, when it's an ion has a 2 minus charge. Okay, so it's oxygen with 2 minuses. Okay, so when it's an oxidation number, it's -2. Now the -2 and 2 minus, okay, they look alike. They're not the same thing, but they're very, very, very close to the same thing, okay? So don't get that mixed up, all right? And the way we even make this is oxidation numbers. It's -2, and when it's a ion, it's the 2 minus, all right? Now usually, but not all the time, the charge is equal to the oxidation number, right? Not all the time, though, okay? It is for oxygen and fluorine usually, okay, but not always. All right, so here's a list of oxidation numbers, and you can actually get them from periodic tables, but we usually just have to do with these guys here. So what I have is I'm going to make chromium X, their oxidation number for chromium X, and oxygen is 2. Okay, so find one of the elements on the table, the highest one, oxygen, and leave the chromium unknown and solve for it. So oxygen is 2 -2, I mean. And so the other thing is the sum of the oxidation numbers times their respective subscripts should equal the charge on a substance. Okay, so what that means is, I'll write this out in a second, is 2, because there's 2 chromiums, times X, the unknown oxidation number for chromium, plus 7 times -2, okay, has to equal -2. Okay, now notice here it's a 2 minus, and here it's a -2, all right? Okay. Now, remember, this is Cr2O7 2 minus, so the 2 minus, this is a polyatomic ion, and it has a 2 minus charge. So, okay, so this is how we set up how to solve for chromium. So I write that out here again, okay. Okay, and here's the equation I just came up with, all right? And then just simple algebra, isolate x, so you add 14 to both sides, plus 14 to both sides, and then you subtract 2 from that 14, and then you'll end up with 2x equals plus 12, and x equals plus 6. So the oxidation number for chromium in this here is plus 6. So often what I like to do is actually write it above it. So chromium is plus 6 and oxygen is minus 2. Okay, so now let's do the same thing with hydroxide. So you look at the periodic table, and on the priority table, and oxygen is minus 2, and that means we're going to leave hydrogen X. I know it says plus 1 there, but I said you always want to leave one unknown. Okay, so if you had 3 elements, you'd try to pick 2 from the table and leave one unknown. Okay, so oxygen higher on the table, and its oxidation, its oxidation number, which is minus 2. Leave the hydrogen unknown, so let X equal hydrogen's oxidation number. Okay, so oxygen, there's one oxygen, has minus 2. Okay, there's one hydrogen, and we don't know its oxidation number. Okay, and so this OH minus has a charge of 1 minus, and we switch that to minus 1. Okay, and so you get minus 2 plus X equals minus 1. Isolate X, solve for X, and you get X is equal to plus 1. Okay, and that's what you would expect from the priority table, because if you look at the periodic table, the priority table, hydrogen has a plus 1. It doesn't always, okay, but most of the time it does. So if we go back here, so OH minus, this is going to have minus 2, and this is going to have a plus 1. Okay, so there's our oxidation numbers for the first 2. Okay, now let's look at CrO4 2 minus. Okay, so remember that this means is that this guy here, CrO4 2 minus, CrO4 has a charge of 2 minus. Oxygen's high on the table, so we leave chromium's oxidation number unknown again. Okay, so what we have is there's one chromium, so 1x, plus 4 times minus 2 has to equal minus 2. All right, solve for x, and you get x is plus 6. So in this case, let me write it over here, chromium is plus 6, and the oxygen is minus 2. Okay, and finally, water, same idea. Oxygen's higher on the table. Leave hydrogen unknown, so you have 2 times x, because there are 2 hydrogens, plus 1 times minus 2. There's one oxygen, and it's a minus 2, equals 0. There's no charge on this guy. Okay, then the solve for x, and you get x is equal to plus 1. So both hydrogens have a plus 1, and the oxygen has a minus 2. Okay, so those are the oxidation numbers for all the elements. But let's put it together in the chemical reaction, and really, and what we want to do is see if this can help us decide what's being oxidized and reduced. That's what happens in chemistry. Is there's most of chemistry that we cover is about gaining and losing electrons. All right, so oxidation is losing electrons, reduction is gaining electrons. So let's look at the big picture. So chromium goes plus 6 to plus 6, so it looks like nothing happens to it in terms of oxidation reduction. Oxygen, same thing, and hydrogen, same thing. Okay, so that's really odd. Okay, because it doesn't seem like anything's being oxidized and reduced. Okay. All right, so by using these numbers, it looks like it. So so far, everything's right. Okay, all the numbers are right, but there's something else going on, and that's kind of cool thing about this, and gaining an intuition about understanding what's going on with chemical reaction. So let's take a look at it, because something is being oxidized and reduced. We need. Okay, so let's take a look at what is going on. So this there is oxidation reduction taking place in this reaction. One thing you have to know is, and it's not explicitly told in this problem, is that this reaction is happening in water. So it's an aqueous solution. So each one of these species are floating around in the water. Okay, uh, and this water comes from the equation, but it's all of this is taking place in water. All right. So one of the things that has to happen is this guy right here, to get it into water, had to come from had to have originally a positive ion attached to it, either an H plus or a salt. Okay, and this guy here is going to end up with that corresponding salt as well. But we leave that off because they end up canceling out. So maybe there was two NAs or something. So it might have been Na2, Na. So when you put this into solution as a solid, it might have been Na plus, Na2, Na plus two of them, and what happens is that the sodium separated from the Cr2O7, and then the reaction took place, but the Na is floating around in the solution anymore. But because it's the same on both sides, we don't worry about it. Okay, so to keep that in mind, I don't know if it was sodium or not. It might have been some other ion. It could have been. Could even be the associated polyatomic ion with this guy. All right, but so we have to look a little bit more closely to the reaction than just numbers. We have to know what's taking place and actually look at the reaction and try to think about it. Now, the key thing here is notice that there is an OH minus on the reactant side, and there's water on the product side. So for what this means is that the OH must have become water. Okay, so OH minus must have been neutralized to form water. All right. Okay, now how did it do that? Okay, now it's hard to see. Okay, so one of the things that probably would happen in this reaction is probably an acid was associated with this reaction. So it could have been that it's in the presence of maybe like hydrochloric acid. And the hydrochloric acid would add at least one of the H pluses, which would neutralize the OH minus. I know there's two of them here, but it ends up working out in terms of stoichiometry. So this OH must have been neutralized by some H pluses. Okay, so the solution has gone from a basic solution, OH minus, to a neutral solution, H2O. Okay, to do this, the base must have gained protons. All right, okay, which means it's gained a positive charge. And that's going to tell us if this reaction's been oxidized or reduced. Okay, when something gains positive charge or losing charge, negative charge, we say it's oxidized. Okay, so what's happening is this OH minus is being oxidized. So it's not just one atom, all right? It's the whole species that gets oxidized. All right, now a review of oxidation reduction. If you lose electrons, okay, if you lose electrons, like lose minus, that means you become more positive. So get H plus. So one of the ways to get more positive is to gain protons, H plus. Okay. The other one is if you're being reduced, you're gaining electrons, right? And that means that means you're gaining negative. Another way to gain negative is become less positive or to lose protons. Okay, and we can see that this case right here, the oxidation, it's this reaction is gain positive. So that means it's been oxidized. All right, so that this problem was a good problem because it's you figure out the oxidation numbers, and then you try to figure out what's being oxidized and reduced. But you realize is that nothing's there, but that means you need to really look closely at the reaction to see what's going on with it. Okay, so OH minus is a base, and so it's neutralized. So that means it must have gained protons. That means it got more positive, which means it's become less negative, which means it's oxidized. Okay. Hopefully that helps you. Okay. All right.